There are some interesting things that we can look at by combining multiple filters together in series. Here we're going to use our simple low-pass filter and simple high-pass filters as our main processing blocks that we'll put together in different combinations. For our first example, we're going to take an input signal and process it by a low-pass filter followed by a high-pass filter. Our intuition would tell us that we're first going to reduce the amplitude of high frequencies, and then we're going to reduce the amplitude of low frequencies, so we should create something that's like a bandpass filter. We'll analyze this by taking the impulse response of both filters together in series. For our second example, we'll look at what happens if we put two low-pass filters in series. The first low-pass filter should reduce the amplitude of our high frequencies by one amount. And then when we go through another low-pass filter, it should further reduce the amplitude of the high frequencies. So this is a way we can think about being able to change the slope and the roll-off of our different kinds of filters that we create. We'll do the same thing in our third example with the high-pass filters. This will give us a foundation for being able to create more sophisticated types of filters in the future. So let's switch over to MATLAB and go through these different examples combining multiple filters together in series. Here in MATLAB, I've started a script called series filters that I'll use for each one of these examples. The idea is we're going to take some of our filters that we've created before as our basic building blocks and put them together in series. So our first one is going to put together a low-pass filter that we've looked at before here with this script called basic filter. We're going to use that, and then we're also going to use a high-pass filter over here. So the approach will be to take the impulse response of the entire thing together. So we take our input signal, feed it through one filter, and then take the output of that filter and feed it into the next one. So I'll grab some of this code that we can reuse, our input signal, and then this loop creates for us that filtering process. So I'll grab this and bring it over to our series filter. We're going to start out with X, and then we also want to create an output signal from this filter. But for this one, I'm going to switch it over to W. So W acts as the signal in between the two filters. So instead of Y will be our output of the whole entire thing. So we take our input, combine it together with the previous sample, scale it in amplitude, and then we store that into W. Now what we'll do is use W going into our high-pass filter. So take some of this code that does the high-pass filtering. Come over here, and we'll perform that. So we will end up with Y at the output, but the thing we need to change is for this filtering, we're going to be using W. And this is how we can set up to do this series processing. We create one signal out of the low-pass filter, and the output of the low-pass filter is the input to our high-pass filter. So I'm going to call this one high-pass filter, so we can keep these things straight. And this one will be called our low-pass filter. So the question then comes up, what happens when we put these things together? So for instance, we can plot W, freq Z of W, and let's also print it out down below to the command window so we can see it. I'll just do that by putting in W here without the semicolon on the end. Then after we go through our high-pass filter, let's also look at that. So I'll create a new figure, and now we'll do freq Z of Y, and also print Y out down below in the command window so we can look at that whole thing. So just a quick refresher, low pass filter, add together the input with the previous sample. Our high pass filter, we have this gain term of -1. So we can look at the result now when we go through the entire process, one after the other. So I'll run this script. We got two figures. Our first one is our low pass filter. That's W. Passes the low frequencies and reduces the amplitude of the high frequencies. Our second figure is the combination of the two filters together. We're still going to have the high frequencies rolled off as a result of W, but then we add into it also this attenuation of the low frequencies. So what does this end up looking like? It ends up looking like a bandpass filter. Let's come down and check out the impulse responses. Compare W and Y together. So as we would expect, our low pass filter has an impulse response of 0.5, 0.5. If I switch back over to this other script, this is exactly what we had before. We had an impulse response of 0.5 and 0.5. So that's working correctly. Then let's take a look at our combined impulse response. So in this case, we have the gain of our dry path. That's going to be 0.25. Then one sample of delay has a gain of 0, and two samples of delay has a gain of negative 0.25. So what does this remind us of? Well, even just looking at the picture, our plot should remind us of this bandpass filter. Let's go back and look at the impulse response here. It was 0.5, 0, negative 0.5. So the only difference between these two impulse responses is a gain factor of 0.5. If we wanted these things to be identical, could actually come back here to the series filter and go ahead and remove this other 0.5. So it's just an extra scalar by a half. So now we can look at Y and compare it to the impulse response of our bandpass filter. Okay, so we've got W and we've got Y. So what we're seeing here is if we put a low pass filter in series with a high pass filter, what kind of filter do we create? We create a bandpass filter. And the impulse response that we get here is exactly the same one that we came up with when we were just doing this conceptually, thinking about how we could modify our basic filtering and come up with this. So another thing to point out here is that when we put multiple filters like this together in series, we can rearrange the entire filter and just create it using parallel processing of one sample of delay, two samples of delay, three samples of delay, and four samples of delay. So different ways to think about it. If it's helpful to say, all right, if I want to create a bandpass filter, low pass followed by high pass, and then what our impulse response tells us is what is the combined thing as this standard way of setting up parallel delays, combining those together. So we've created now our bandpass filter. Hopefully that is somewhat intuitive for putting together these two filters. Let's look at what happens when we put two low pass filters together in series. Here's our low pass filter. So the difference here is we want to change this from -1 to +1. So that will also be a low pass filter. I'm also going to stick this gain back in here so that both filters are unity gain. So we'll go through the same analysis here where we can look at one low pass filter by itself and then a second low pass filter in series, compare the impulse response in the plots. So I'll drag these side by side so we can compare them here. And you can already start to see it, the slope and the roll-off of these two filters. So the one on the left is W. That's a single low-pass filter. See the amount of attenuation that we get over here. Now compare that to putting two of these things together in series. That's what figure 2 is over here. The amount of roll-off is going to be twice the amount for these different frequencies. So all the way up here at Nyquist, we have what the plot shows to be about -50. Well, if we look at the same frequency over here, it is twice the amount, -100. If we go in and find some frequency along here, maybe it's 0.75 normalized frequency, and that's -16, -17. If we do a similar thing over here, -7.5, we're getting somewhere in the range of like -8 dB of attenuation. So the way to think about it is you put multiple filters together in series. The first one decreases the amplitude by a little bit, and the second one decreases it by more. So this is a way that we can actually create filters that have sharper slopes, greater attenuation, all that kind of stuff. All these different degrees of freedom that we like to be able to control, we can do so by putting multiple filters together in series. And that will give us this kind of impulse response. So we've got one sample of delay, two samples of delay, and three samples of delay. So we have stepped it up from just having the current sample combined with the previous sample to now we're going to take the current sample and combine it with the previous sample and also 2 samples of delay. So if we want to create sharper filters, one thing we've got to do is make use of additional samples of delay. And what that's called is the filter order. What we've done is increase the order from having 1 sample of delay here to now we've increased the order and now we're using 1 and 2 samples of delay. And that's going to be an important part about creating more sophisticated kinds of filters, increasing the filter order. So let's recreate this process using 2 high-pass filters now. So let's switch this over. See that we end up with a very similar kind of result or complementary kind of result. 2 high-pass filters. So this one should have a gain here of -1 multiplied by the previous sample. And this one should also be -1 times the previous sample. Do this again. We've got high-pass filters, extra attenuation over here for the combined series high-pass filters. This is just a single one. And similar thing happens for our impulse response. We've just got 1 sample of delay here. If we want to have a sharper high-pass filter, we need to have a higher order, -0.5 and -0.25. If you remember from our low-pass filter, what the impulse response is, now compared to our high-pass filter, it's again complementary. The only difference was this second term was negative. So there is some relationship between the low-pass filters and the high-pass filters. In summary, what we've been able to do is combine multiple filters together in series. Hopefully, it was intuitive to think about if we do certain combinations, it's going to create for us a bandpass filter or a low-pass filter or high-pass filter with different slopes and attenuation. We also discussed moving forward how this is going to open up for us all kinds of different possibilities and lay the framework and foundation for us to create more sophisticated kinds of filters by increasing the filter order.